Спасибо.
Следующее к выступлению подходит Найду Анураг Naidu и готовится к выступлению Манож Чодри.
Мощнейшая защита. Платформу создали, а теперь они находятся.
Good morning, ladies and gentlemen. Good morning, respected guests, moderators, everyone. Before I start my presentation, I want to seek your attention on a few issues which are really important to understand my presentation. It's not completely related to IT, it's not a software development, but it's about intelligent manufacturing. Before I tell you more about the project, you must understand what is a lathe machine and how the machining operation happens. With the use of vibrations, I would be able to detect the life of any cutting tool, any machine available in the world using vibrations and acoustics. We will also look at a few aspects of MATLAB, using MATLAB and artificial intelligence and developing a neural network, a feed-forward neural network. We will set up a pattern in which we can determine the life of the cutting tool. So, guys and girls, this is a lathe machine. For those who doesn't know the operation of the lathe machine, I can explain to you. The one spindle which is kept there, the tool is naturally kept there, and it rotates at certain speed. It rotates at certain speed, and there is a manufacturing tool which is attached to the saddle, and it gets in contact with the tool rotates, and the manufacturing tool gets in contact with it, and you get a desired shape. This is the operation of a lathe machine. And this is a piezoelectric sensor. The beauty about this project is this is the cheapest way of intelligent manufacturing in the world. It's a simple piezoelectric sensor which we use for our treadmills and TMT, obviously for the cardiac patients. So just to tell you more about my project, we did 174 rounds of data sampling while manufacturing, and the vibrations and the acoustics were recorded. And we eventually mapped it against time domain analysis and also frequency domain analysis. Time against frequency, and again time against amplitude. So this was the work. Whenever a cutting takes place in any machine, there are three major parameters which comes into play. One is the cutting speed, one is the depth of cut, and one is the feed rate. So we have three combinations. So what I did basically, I made the permutation combination of this with the cutting speed constant, depth of cut constant, I varied the feed rate. So I get 6 combinations with this. Again, by keeping the feed rate constant, cutting speed constant, I varied the depth of cut. Again, I made 6 samplings for this. So when I did like this, what I can briefly tell you is this. When I kept the cutting speed of the machine at 20 meters per minute and the feed rate was 0.15 mm per revolution, and the depth of cut I kept was 0.5 mm. At this point, what I saw was when I mapped amplitude against time, it was ranging at the range of plus 0.1 to minus 0.2, as you can see here. It determines a pattern. It determines a pattern when the tool is fresh. The tool is fresh when the first working condition. As we see the tool is getting worn out, the vibrations increase. It's but natural, the vibrations increase, and I've recorded the pattern. In this, what I've done is I've increased the depth of cut from 0.5 mm to 0.75 mm. So obviously the vibrations will be more. This is just a pattern to make sure that we are going at the right path. It is a validation tool. So similarly, I kept on weighting all these things. As you can see, the graph moves on. See the amplitudes are increasing. And if you see the kurtosis of this amplitude, it's very dense. It's happening because the tool is getting worn out. Same will happen with engine. If a new engine is there, the vibrations will be less. If the engine runs at maybe covers 50,000 kilometers, the vibrations will have a specific pattern to it. If the engine runs as 1 lakh kilometer, the vibration will have a specific pattern to it. And that will be common for all the engines. We can derive for the fixed parameters. If I talk about 1.5 liter Volkswagen diesel direct core injection, it will have a fixed pattern, obviously. With the kind of parameters, we need to go to the MATLAB. With our artificial intelligence, we will calibrate once. Just like what I did, I calibrated the vibrations and the acoustics, and I derived the pattern. And when I derive the pattern, I make a trend. And afterward I make a trend, this is very important, that I take it again to the frequency domain. Okay? Even if I don't look at the amplitude, I must validate the frequency as well. And from the initial stages to the advanced stages, I've seen the pattern. You can see the pattern increases and the density of kurtosis and the standard deviation goes up. It's a long presentation, that's what I'm cruising through. So when I receive the data, finally I compile the data into like this. When I see the depth of cut, I've been varying from 0.5 mm to 0.75 mm. As I told in the start of the presentation, I got the average RMS values, average kurtosis values, and average standard deviation values, as well as average skewness values. So this is the behavior of the machine through vibrations. Now what I did, I made graphs of it just to analyze. You can see the average standard deviation goes down, skewness goes down, then RMS goes down, in fact, average standard deviation goes up, and again kurtosis goes down. So after I did all this, I came to MATLAB. I developed the software, I developed an artificial neural network, okay? I input it for 10 seconds data, okay? And I go to a feed-forward neural network. What does feed-forward neural network? It's very important to understand the architecture of this feed-forward neural network. We are inputting 3 values. In my case, we were inputting 3 values. It's just a diagram, it's got 5 values. When 3 values goes in, there are 3 values in the middle. The most possible permutation and combinations are there. And after refining the data with each other, the refined data comes out of it. Those of you who know very well MATLAB, artificial intelligence and the neural network, the neural network of feed-forward works like this. And we have streamlined the data. The combination with purple color and the yellow color and orange color, we have streamlined and we've derived a pattern. So the computer now understands the language of vibration of a machine. The computer has started to understand. Once this calibration is done, just for my case, I calibrated and I trained the data for 72, and the number of target epochs I set for 1000, and I achieved the target at 945. After 945, I got the value that the engine performance or any machining performance was set to the computer. The language could be understood by the computer, and there I derive a pattern. Once I derive the pattern, I look for some different cases. I take some unknown data and put it in I train them into the ANN. When I put the unknown data, it gives me a pattern. Okay, I see that it's working. Now what I do is, I take a random data from anywhere, just to check the ANN is working fine. I see that the ANN again works very well. Then I put the unknown data and again reevaluate. I see that the ANN is working again very fine. Then again I see the corresponding set of graphs, I match with it, they are very close, the pattern is very close, and I achieve at the conclusion. What I'm going to tell you is, any machine which generates vibration, the language of the machine can be identified. If I'm clapping now with an energy of maybe 100 calories, I had 2 cookies and a soft drink, maybe at this point in time, the vibration of my claps will be something. Maybe after losing 50 calories energy, okay, the vibration of my claps may be something else. So this language should be understood by the computer. When the computer starts understanding this for any machine, any body, the pattern can be recognized, and we can then do it very easily with a piezoelectric sensor. In India, it costs around 2,500 rupees, maybe around 2,000 rupees. So, that's all I have for the presentation. Thank you very much for listening to me.
Tata Motors invested to you?
Mahindra. I work for Mahindra, SsangYong Motors. Yeah, but they have not taken it up yet. I've given a proposal for NVH. When they develop a vehicle, they go for NVH, noise, vibration and harness. They do it the same pattern, but they pay a lot to the Italian consultants for that. So I gave this a cheap solution that we can do it in-house. It is under consideration, but this is the cheapest solution that we can have.
So, how can we scale So, what product can you make with your research?
The product is nothing but a sensor. If you give me a sensor, and if a machine is a case for us, we go and put our sensor, we record the vibration of the machine. So what affects the machine? Say the machine, oil affects the machine, say petrol affects the machine, okay? And the running speed, the acceleration affects the machine. So these are the 3 parameters. Taking these 3 parameters, we will go with the same pattern. Once we achieve the pattern, the pattern of artificial neural network is a patent for us. Is our invention. Once we get that, say for a Volkswagen engine or maybe a Kia engine, when we set this data, this is our data, that is our language. We have created the language. And then we can take it up to the market, because for us it's of no investment. And we can tell, one important thing, we can also record the machine vibrations in the real time in any place. Through Internet of Things, we can sit in the university and calibrate the engines. This is one big innovation, and it has no cost at all. But we need a MATLAB software for that. Any more questions?
Is it a project or product or idea? What do you think?
It's a project. It's a project right now.
How much people work in this project?
Me and my professor. We didn't disclose this. But it has wide application. It has wide application.
Большое спасибо.
Time for спасибо. Thank you. Ladies and gentlemen.
К выступлению подходит Манож Чотри, готовится Гуара Агарвал.